Hello and welcome to SAE Tomorrow Today. I am your host, Grayson Brulte. On today's episode, we're absolutely honored to have Dave Fulton, Engineering Director, Electric Machine Innovation, BorgWarner, and Monty Hayes, Global Director, Electronics Hardware Growth Innovation, BorgWarner. On today's episode, we discussed the shift to electrification and how BorgWarner is embracing electrification and efficiently scaling their business as it moves from internal combustion engines to electrification. We hope you enjoy this episode. Gentlemen, welcome to the podcast.
Thank you. Nice to be here.
Thank you.
It's very nice to have you here. BorgWarner is a fascinating company that's going through a big change from internal combustion engines to electrification, so I can't wait to dive into that conversation today. You gentlemen are the perfect individuals to lead this effort. You've been working on electrification for over 30 years now. Reflecting on those 30 years, how has electrification changed? Dave, we'll start with you, and then Monty, I'd like your thoughts as well.
For one, it's increased in scale dramatically. Electrification is not a fledgling area. It's a primary path for the future. That means a lot more people, a lot more collaborators internally and outside the company. It's a lot more complex to manage, but it also means a lot more investment. That's a good thing as well. So I think globalization and the increased scale are two areas that I would say. I think better engineering tools. We can do things faster. We've got parallel computing capability that allows us to do design optimization very quickly. And that's essential for today's fast cycle times to turn designs around quickly.
That's a fascinating line. Primary path for the future. You're 100% right on that. More investment. Boy, oh boy, we read the headlines every day. More and billions of dollars are being committed to electrification, where earlier that wasn't the case. Monty, what are your thoughts reflecting on that 30 years of experience?
We still see customers today looking for solutions with a smaller volume and mass, increased efficiency, and lower cost. And while the fundamental solutions are similar, we've continued to evolve the technologies and the materials to address these needs for higher efficiencies and lower costs, such as wide bandgap materials, non-rare earth metals, new battery chemistries, along with the movement to higher voltages that we see with 800-volt bus voltages. The other thing, too, I think we see in the industry is as we drive for this carbon neutrality and lower cost components, there's been a wider adoption of electrification and e-mobility space, including the light duty and commercial vehicles. So I think that's helping to drive it, the changes.
How are you able to do it with non-rare earth metals? You read reports that this manufacturer, this OEM, they need the rare earth metals. How's BorgWarner able to do that?
We can't insulate ourselves from changes in material pricing like rare earth metals, and we know that historically, back like the 2010 timeframe, rare earth metals spiked in price, has come down since then quite a bit. But I think it's really important that we maintain an agile stance where we can to provide options that are non-rare earth based. For instance, making induction rotors or wound rotors for motors, allowing ourselves to change from one technology to another if you have a sustained price increase for a long time. I mean, if it's just a blip and comes back down, those aren't going to change people's buying behaviors. But something where it becomes a pain point, it's really important to try to, where possible, provide options in different types of technology. And I think in motors, that's a good case in point.
It's a smart strategy. It's you're leaving your options on the table, and you're doing one of the most important things today in a changing society. You're giving flexibility. And Monty, as I said earlier, BorgWarner's known for a lot of things. Individuals inside of the automotive industry know BorgWarner, like BorgWarner, respect BorgWarner. But for an individual that's listening, that is a casual listener, says, well, this is interesting. How would you describe BorgWarner and the role that it plays in the automotive ecosystem?
BorgWarner today covers a broad gamut of products and portfolio for the automotive. We're still strongly embedded in the combustion vehicle space today. We're working to further continue and evolve, better efficiency, higher efficiency, lower emissions in the combustion space. But then we're also pivoting and transitioning to electrification. So we're covering, not only electronics, but electric machines, integrated drive systems, gearboxes, battery management, battery solutions and technologies. So I think we cover the full gamut of products and portfolio needed for the electrified drivetrain.
And in other words, you're playing a very critical role in the future of electrification.
Our goal was to be a key supplier to the various components or systems that the OEMs need today, for not only for light duty but also for commercial vehicle applications.
The commercial vehicle applications, that market's going to be really interesting as it evolves. We had the $900 million first round from BlackRock, Nextera, and Daimler Trucks North America committed to building out the charging infrastructure. That's an industry that I'm really waiting to see grows. And as you said, BorgWarner will play a significant role in that future. Monty, from a strategy perspective, how is BorgWarner positioning the company for this giant shift to electrification?
Yeah, I mean, there's a couple of things. I think we've had a proven track record of bringing successful mobility innovations to the marketplace, and we've been preparing for this transition for some time. So I think this is made up of three major areas. One is, as we pivot to electrification, we're doing that through organic growth initiatives to complement our current EV portfolio through mergers and acquisitions. We had the merger and acquisition of REME in 2015 for rotating electric machines. We had the acquisition of Delphi Technologies in 2020. We recently had the acquisitions, which was completed in February of this year, for the AKASOL for battery packs and modules. And then we have the pending acquisition that was just announced recently for Santrol for electric machines. So combining these acquisitions with our organic growth, and then we're also continuing to optimize our combustion portfolio, because that's still an important part of the business that we have today.
It all comes down to optimization and staying flexible. Dave, from an engineering perspective, how are electric propulsion systems designed and manufactured?
It's a pretty complex system, so we start at the top level and look at it from a system point of view. What are we trying to do? What are the goals for that propulsion system? And then a system architect will then break those down into requirements for each of the components. So if you think about the power flow in an electric vehicle, it starts at the battery, goes through the inverter, hardware, and it's controlled by the software. Those requirements at those levels, and for the motor and then the driveline. Each one of those components has a different set of technical experts who then take those requirements and use computer optimization tools to weigh trade-offs between, say, performance and efficiency, cost and efficiency. There are things you can do to spend more money to be more efficient. What's the right balance? And then a level above that, that system architect is using computer optimization tools to trade off one component against the other. There are things you can do to make an inverter run at a higher frequency, and that allows it to make machines or motors more efficient. However, it can compromise the efficiency of the inverter in the process. So those are trade-offs that we constantly have to look at, because in the end, those components have to serve the greater good of the whole propulsion system. So finding those balances inside the components and component to component is crucial to our success. But as you're doing that, you have to think about building blocks to be modular so that you get economies of scale and keep the cost low at the same time as trying to make a really efficient and high-performing system. So in an inverter, for instance, you can have different kinds of inverters in terms of power rating, but they might use all the same power module and use a different number of them, and they're connected differently. But basically, you're getting those building block economies of scale in different kinds of products. And in motors, the same thing. You can use a lot of common parts and get different performances out of motors, or motors that are 400 volt or 800 volt, as we're seeing the transition in the market now today. So we have to we don't want to design a product in a vacuum. We have to have an eye towards what else those pieces are going to be useful for, to make them so they work together across the whole product portfolio. And that keeps costs low for our customers. And I think on the manufacturing side, we've got to make sure that our parts that we're designing are producible at high volume around the world, using processes that are similar for similar products, so that as we learn things about how to improve, we can apply those learnings anywhere in the world, everywhere in the world. And that becomes something, again, that translates to cost and a better value prop for our customers.
You mentioned computer optimization tools. Is that simulation, or could you expand more on that? That seems really interesting.
Yeah, simulation is a huge part of what we do, and you can do more of that than we've ever been able to do before. And you can do it in different areas. We can simulate what's going on thermally, electromagnetically, even in the insulation system, how the insulation system behaves over time to make sure it's durable. These are all things that can be done with simulation. It doesn't take away the need to test at the end. We still have to do validation testing and make sure the simulation is right on. But it greatly reduces the amount of trial and error and iteration. And so allowing the computer to weigh many thousands of designs against each other to find the best outcome is something that's just part of what we do now on a regular basis.
Throughout the theme of this conversation, there's been one theme is efficiency. Is simulation a tool that you would put in the efficiency camp where it's allowing BorgWarner to efficiently develop products?
Yes. You don't want surprises. These products are so expensive to build and to test. You really don't want any surprises. Tweaking is okay, but a total surprise is not. And so these simulation tools are going to red flag you if you have an issue that's going to happen. These are where we see these. We've got standard analyses that we run to make sure that we're going through each product, whether it's an inverter, a motor, battery pack, and we're checking it from a vibration robustness point of view, or from making sure it doesn't overheat and so forth, making sure it's not too noisy even. A motor, for instance, has an audible noise to it. We got to make sure that even though EVs are known for being very quiet, we have to watch that and make sure that this motor in fact meets all those requirements.
Noise is a theme throughout several of the podcasts that we have that comes up. I think it's going to be a larger thing that companies look to minimize noise for their products, whether ground or air. And Monty, staying on the efficiency theme, how is BorgWarner optimizing each component of the powertrain to ensure the ultimate efficiencies?
It's done twofold, right? I think on one hand, it's done by the components, optimizing our inverters, onboard chargers, DC-DC converters, the electric machine and the gearbox separately. But then there's also that optimization of the components together for like an integrated drive module where you have the inverter, electric machine, and the gearbox together. So, as you look at things we're looking at today, we look at optimization for inverter performance. We're looking to move towards wide bandgap devices. So we're moving towards silicon carbide devices versus silicon devices. Similarly, for onboard chargers and DC-DC converters, we're moving towards gallium nitride based devices. But we also looking at improved custom ASICs that will allow up integration and integration of functions into the controllers. As we pivot from custom ASICs on combustion engine vehicles to electrification, that's another area of improvement. Capacitor technologies, as we've talked about, the optimization of the electric machine performance for either permanent magnet or non-permanent magnet machines. And so I think, couple that with new battery technologies and new topologies, we're looking at it not only at the component level, but also integration of those components together and optimizing that at the systems level. And I think Dave touched on an important point earlier. Not only are we doing the simulations and design and development of these components at a component level, we're also putting these together and optimizing at the system level. So whereas you might sub-optimize one component performance, you might optimize the total system performance for the electrified powertrain.
Could you expand more on the optimizing at the system level, please?
I think, as we look at it, not only do you need to optimize the components, as I mentioned, you need to look at it, the customer drive profiles, right? There's different applications, different drive pros for the light duty vehicle, also for the commercial vehicle applications. They may have different peak currents or different continuous currents that you need to operate or design for, different coolant solutions. So all those, optimization of all those different components, such as, flow, pressure drop, losses at the system level, combining that with the gearbox and the overall performance with the electric machine is important as we look at the total solution. So you might have to look at a certain operating point where you want to optimize for, right? Some say a light duty vehicle may spend a lot of time at very low currents, 50 to 70 amps. So is where you want to optimize for the switching losses and performance there. So it's just, you just need to look at each individual application across the customers and optimize the total system for that.
It's a smart business strategy, and your customers are the OEMs, the large car manufacturers around the world. Monty, how much insight and feedback do you gather from your customers as you look to optimize and increase efficiencies in the products that you develop for them?
we supply to most of the major OEMs globally today. So one of the key things is we get a lot of feedback. We get to see a lot of specifications. We get to see the various implementations that the customers are doing for their vehicles. So I think we take that all in hand and look at where the market's going. The other thing I should highlight is not only getting the customer feedback, but we have a talented team of our corporate advanced team to look at okay, instead of getting a pull from the customer, what we think the technology should be, right? Where we think the next bus voltages are going, or where we think the next vehicle architecture is going to go, right? So we keep track of that and try to look to develop those technologies up front and push some of those technologies in addition to getting pulled from the customer.
That's really smart. And Dave, your customers, they go out and press releases or go on business news programming, and they're talking about electrification, and we have the whole rare earth minerals debate now, and then we have the refining issue. Raises the question, what impact do the commodity markets have on how BorgWarner's approaching electrification?
It's not going to be possible to completely insulate ourselves from those fluctuations. I think the main thing is to be able to provide options if you have a sustained shift in pricing that's significant. And that can be the type of switching technology, for instance, you might use, whether it's silicon carbide or silicon, or it could be the type of rotor technology with rare earth or non-rare earth. There are different directions you can take things. It could be the battery chemistry that might use nickel or no nickel, that kind of thing. So there are choices that you can make. The question is how much is going to be economical to prepare for on-the-fly type changes. I mean, there are certain things that will just find their way into customer requests. If customers find there's too much pain in, for instance, having rare earth magnets, they won't send you a general request for a motor quote without specifying the chemistry or the type of motor. They're going to be very specific about what type of motor they want. And that's not even unusual even today. So I think those are things we just have to be smart about. You can't prepare for everything, and some things are a pass-through. You can't avoid certain ripple effects of commodity changes, but you can say, based on history or where we think things will go with demand, what might we do if we see big price changes in a certain area? You can be more intensive in an area that is lower cost, and that's just an option we have to give ourselves and give our customers.
That's a really great answer. Monty, markets are changing. The automotive industry is becoming the mobility industry. How is BorgWarner staying ahead of the trends in the market?
I think we need to keep abreast of what the customers are looking for, but and the end consumer, what they're looking for in the marketplace. But we continue to take our key developments, and we're doing that through organic growth. We're doing key investments in the marketplace. We're making strategic acquisitions, and then, as I mentioned, we continue to look at our developing a advanced emissions reducing and fuel efficient combustion solutions as we go today. So part of it is continuing to work on the products that we have today, and the other part is trying to be continue to look forward where the market's going to go, not only from a OEM standpoint, but where we think BorgWarner thinks it should is going to go.
It's the old Gretzky analogy. You're skating to where the puck's going to be, not where the puck is.
Right, and you have to invest in that up front to have some strategic view of where things should be, and how you can get there with new materials development and key technology development as we move forward.
And BorgWarner's investing, Dave. On March 23rd, 2021, BorgWarner introduced Project Charging Forward to accelerate the company's electrification strategy. Big announcement, big investment. What can you share about the strategy?
Yeah, I think Monty touched on this before, that it has basically three components to it. The one is scaling up profitably what we've already got in terms of portfolio for electrification. And we're doing that. We're adding capacity. We're adding in our test areas. We're constantly hiring great people in that space. The other is going to build on that with complementary outside entities through mergers and acquisitions, and that helps us. Some of the ones that we've mentioned before about Santrol, for instance, a pending acquisition, and we've continued to keep an eye on startups and other places where we might be able to complement what we've already done. And then the last is because combustion powertrains are going to be a large part of the transportation sector for some time to come. Even though it's a transition down, it's still a long transition. We want to optimize our combustion product portfolio to make sure that we're supporting our customers through that whole transition from combustion powertrain dominant to electrification dominant.
Monty, as Dave described elegantly, is that how you're investing in electrification without disrupting your ICE business?
We continue to have organic growth. We've had the key investments in strategic acquisitions, as I mentioned before, and we continue to develop our fuel efficient combustion energy products today. So we're not taking away necessarily from our development from the combustion energy, but we're augmenting it with our key acquisitions and growth.
And Monty, putting some numbers behind this, BorgWarner's currently projecting your electric vehicle revenue is 3% of total revenues today. It'll be 45% by 2030. That's a gain of 42%. How's that goal going to be achieved?
We look at our total portfolio of products today. So, we have with the recent acquisitions, we have everything across the spectrum needed for the electrified powertrain. So we have the battery products, we have electronics and electrification with inverters, onboard chargers, DC to DC converters, controllers, heating products, in addition to the rotating electric machines and the gearboxes, which combine for our IDM systems, integrated drive module systems. So, we have the full spectrum of products that will be able to meet the customer's needs. Either customers that want to buy specific components separately as standalone components, or if they would like to have up-integrated solutions, we have the ability to cover those different activities and products. So I think that's going to help propel us as we pivot from the combustion engine to the electrification.
It's another way of saying that BorgWarner's customers today will be your customers tomorrow, and they can grow with you as the mobility industry transforms from ICE to electrification. BorgWarner's there to help them on that transition.
Right, exactly.
Dave, we've talked about this a lot. The mobility business is shifting to electrification, and that raises the question around sustainability. What are BorgWarner's sustainability goals?
Broadly, they fall in two areas. One is in operations, our manufacturing operations and all our tech centers. And basically, our commitment there is to be carbon neutral in our operations by 2035. The other is basically in the product in-use emissions that we're selling, and basically that relates directly back to the goal of the 45% revenue from EVs by 2030. So that's a significant change in our carbon footprint that we're introducing through the products that we sell over the life of the product. And as we get more and more renewable energy sources where we sell products, that's going to improve the impact of that as well. But even without changing the combination of renewables versus fossil fuel energy sources, it's still a significant reduction in overall carbon emissions.
It's a positive step, and I'm sure that BorgWarner has a lot of data centers. The decarbonization of data centers is becoming a really big trend now. As you work to achieve your 2035 carbon neutral goals, that'll probably be a part of it as well. That's the technical wonky stuff, but your consumer goes into the showroom or online and orders an electric vehicle. And I ask myself, at the end of the life of the EV, what happens? What parts of the EV can be recycled? You've got a great engineering background, Dave. I'd love to know your thoughts on the end of life for an EV.
Yeah, I mean, it's hard to answer for the whole vehicle. And of course, it changes with where you are in the world, what's happening to vehicles at end of life. But I think our focus is to make sure that things are recyclable in an economical way. And I think that in the future, our laws and around the world, as well as our customers, are going to be more focused on a circular economy, looking at not just the initial cost of manufacture, but the total cost, product lifecycle cost of the manufacturing cost, plus the cost it takes to recover all those materials and reuse them. And one of the areas, I could use the motor as an example. I mean, most of the things in the motor today are going to be recyclable. The aluminum housing, steel laminations, the copper winding, all those things have a good history of being able to be recycled and are in fact being recycled on a large scale. The thing that's a notable exception is rare earth magnets. And rare earth magnets today, there's not an economical way to take them back to their elemental forms where you can reblend them however people are making magnets to the demand of new custom magnets and that sort of thing. And to do that is just not economical, so it's not happening. But there are some ways around that. One would be to not use rare earth magnets, as we talked about, and that is a slight efficiency penalty because rare earth magnet motors today are the most efficient motors overall. So if you want to get around that, another option is to have what some people call magnet-to-magnet recycling or grade-to-grade recycling, which basically says don't try to change the fundamental composition of the magnet, basically kind of remelt it down and reuse it in the same grade. And that there's been studies done on that to show that that's much lower cost and much lower carbon emissions to go through that process than it is to melt it all down, divide it up, and reuse. And it's really nothing new. I mean, when you think about it, we see this today with different categories of plastics recycling. There's certain kinds of plastics we melt down and keep it as that type of plastic. It's not any different than that. The challenge is to do that requires some standardization of materials. You can say, okay, I'll use from this set of however many, 3 or 5 different magnets, and we'll only use from those to make the recycling more economical. So I think this takes some agreement between the manufacturers and customers, and ultimately some restriction of choice. And that happens on, I think, any kind of standardization for the purpose of recycling is always kind of limits our choices. So we just have to be figuring out what's the right balance going forward that serves everybody the best.
That's a great approach, and we have the EU battery passport work that's being done in Europe. That'll be interesting to see what comes of that, and then if that comes over to America, because if you look at Europe, EV vehicles, charging really incubated there, and then we want to say they export them to America, and so it'll be interesting to see if they take the leadership on the standards around the battery material. So that's going to be interesting anyway. So thank you for highlighting that. Monty, is everything shifting to electrification? What impacts do you see happening as it relates to the technology? Do you see, for instance, a vehicle running in a dense urban environment having a smaller battery pack if it's just going from the home to the grocery store versus long range? How do you see electrification evolving as it relates to technology?
Historically, from an evolution standpoint, we've already moved from 12-volt systems and our 48-volt systems, mild hybrid systems, up to the 400-volt bus voltages for BEVs or battery electric vehicles. And then I say as we move forward, we see the continued movement towards higher battery voltage for 800-volt systems for either performance vehicles or larger displacement vehicles, and for faster charging times, right? And then as we see continued evolution, we'll see the movement from silicon-based systems. Although today we still are improving silicon-based semiconductor systems, but we're moving to wide bandgap with better efficiencies. But to your point specifically, I think you'll see tailoring of certain vehicle platforms with the OEMs. They'll have a wide range of platforms basically geared towards individual customer needs. You might have small vehicle needs, performance vehicles, trucks, commercial, light-duty commercial vehicles. Each will have a different solution, although we've looked at, you see some manufacturers out there, OEMs are looking at a sled type of system where they can just put different top hats or different types of product skins on top of the base powertrain. You also see some customers are actually highly customizing for the vehicle application. So I think you're going to see that stratification in the marketplace to some degree across the customers and the different OEMs, depending on what their clientele is.
And you mentioned faster charging times. Does that start to become a growth area, or if you want to call it a race, or who can charge the vehicle faster, and then perhaps that can accelerate consumer demand?
I think it's an important area, right? As we look at the changes from combustion engine vehicle platforms to electrified platforms, that be able to have fast charging times or ways to quickly recharge the vehicle, so people can have use them for longer ranges depending on the application where they're at. I think part of that will be also there will be a limit to infrastructure limit to in some areas of the world, how they can adopt that. The higher voltages or the implementation of that faster charging time. So there's going to be a limit. It's not like you just keep, continue to to increase forever, right, on the capability to make it quicker as we move forward.
Yeah, we don't want a Wile E. Coyote kablooey scene when somebody tries to. We want to avoid that at all costs. Well, it might be funny in a Warner Brothers cartoon. It won't be funny in real life. We're seeing all the trends that are happening, as you pointed out, with electrification, Monty. And then the other side that we haven't touched on, the product design cycle, it's getting shorter and shorter and shorter. Over-the-air updates are seemingly a common feature on vehicles now. If you don't have it, it's like, whoa, you used to have a CD player in your car, and now you need to have OTA. It seems like that's the new de facto feature there. What impact do those shorter and shorter design cycles have on your business?
We continue to see the OEMs today shorten these design times, and it really means that we need to be agile and nimble, right, in the marketplace to be able to address the needs in a quick manner. I think this also applies to our innovation strategy, right? How do we innovate? We need to innovate much quicker. We don't have these long cycles and long design times to innovation or implementation of those products into the marketplace. And I think Dave's point earlier, he highlighted on it, was simulation, right? I think simulation plays an important part of being able to speed up this design cycle, to be able to apply learnings quickly and do it with less resources, right? Because we obviously have the constraints as the industry does today with resources. Obviously we're hiring, but you want to make more efficient use of your workforce that you have to address the needs of the quicker turns.
Dude, that's a great segue. Workforce development is a big topic now. The labor market's a big topic. In my opinion, business and education are like peanut butter and jelly. They complement each other because you should always be learning. And since 1987, BorgWarner's invested $1 million in the SAE Foundation in support of the Collegiate Design Series and a World in Motion education programs. Big commitment. Why did BorgWarner do this?
In general, BorgWarner has a great track record of supporting communities where we live and work. And I think their charter is to go and support in areas of education, economics, the environment, and equity, kind of the 4 E's, if you will. And really, if you think about it, STEM education really is a great fit for all of those. It's directly or indirectly supporting all of those things. It provides a way up for so many people to have great jobs, as well as provides a society with the next generation of problem solvers and game-changing ideas. And I think we recognize that SAE is addressing that at the full age range of education, of students, basically. So starting at the pre-K and going up through college. And so I think it's a great fit, and that's one of the reasons why we've been a faithful supporter. I think we've seen how effective it is.
And Monty, I want to put some numbers to this. The investment that BorgWarner's made has had a positive impact on 64,000 students across 10 countries over the past 10 years alone. That's a lot of impact, a lot of good. What has it meant to the students in BorgWarner's global communities and to the company's business initiatives that the company BorgWarner's continuing to do right by society and invest in education?
Yeah, I think it's really important. And, this allows us to promote the STEM initiatives. It also promotes, our beliefs in access, diversity, inclusion across the globe as we get these students from the various backgrounds and locales to be exposed to these technologies. Also, by engaging these students across all levels, it helps us to promote our goals of a cleaner, safer, healthier future. But more importantly, also importantly, is this also generates excitement for future technologies with the students, and helps us to develop a pipeline of future engineers and technologists, not only for BorgWarner, but globally.
And Dave, you've rolled your sleeves up. You've gone into the classroom. You volunteered over the years as part of SAE's STEM initiatives. Can you share some of those experiences and why you wanted to participate?
Sure. Yeah, I think in general, people who have an excitement about teaching children are usually people who saw the value of it in their own lives when they were a kid. They had the benefit of somebody who really inspired them. And that was the case for me. My parents, my teachers, particularly in STEM subjects, really inspired me to want to learn more on my own. And really, if you can do that, that's the gift that keeps on giving, right? So inspiring kids to taking advantage of that natural curiosity, which really starts right at the pre-K time frame, is such a great springboard that, you think something small like that, how much benefit can I create? But really, again, if you can start something that is somewhat self-sustaining, that's a big seed that you've planted right there. So I think I want to provide that for other kids, other students, the way I experience that. And SAE is a great program that you can plug into to do that. And I did that with a kindergarten, with kindergarten classes through the World in Motion project. And I think it was just great to see how hands-on. It's a great way to learn. It's very fun and engaging. It asks kids what you think is going to happen, and then you ask, did it happen that way? And to see kids wrestle with things that they saw that didn't agree with what their preconceived notions were, that's just part of that whole process of thinking critically. And I think in general, any STEM topic you can start with at such an early age, just showing kids what's possible. And then you can build on that layer later as they start to get math tools and things like that and explain why it happened that way. But a lot of times we put off showing people anything unless we can explain it from A to Z. And I don't really think, I like the way SAE does things. They start at an early age and just kind of show kids what's possible and get them thinking. And I think they follow on later on when they've got more tools under their belt and they start to say, okay, let's look at this a little more quantitatively. Let's graph some things. Let's look and see what we can learn from measurements. And you go on and you build on that to the point where at a college level, you're designing things. You're using those tools and actually designing and building things. And that's a particularly exciting way to, see that progression all the way through. So I'm really, I'm a big fan of what SAE is doing. I think it's you're planting the right seeds at good ages, and I would definitely do that again.
You're providing the child the inspiration to set them on the curiosity rabbit hole. And the next thing you know, you might have said something and the child goes on to invent something that has a positive impact on society because you took the time to roll your sleeves up. You just never know. It's the time to be there. Sheryl Sandberg says this, to be there in the moment, and you're being there in the moment, helping these children learn. And thank you for that, because that's really positive. Monty, this has been a wonderful conversation. We've gone all over the map, and I'm following the curiosity here. What is the future of BorgWarner?
I think BorgWarner has a really bright future, as we drive for a cleaner, safer, and healthier future. We're excited to drive new technologies under our charging forward, with the goal of having the carbon neutrality by 2035. So I think it's a really bright future.
A bright future is an awesome future. And Dave, Monty, as we look to wrap up this super insightful conversation, what would you like our listeners to take away with them? And Dave, we'll start with you, please.
Well, I guess first I'd say we're continuing to hire great people in electrification. So if you have interest, check out our website. BorgWarner's a really good company to work for. And then I guess secondly, if you have opportunity to volunteer for STEM education through SAE or others, I'd highly recommend it. It's a great way to invest in kids and in our future in general.
Investing in the future is a positive thing. Monty, please.
Yeah, I agree. I mean, BorgWarner is a company that's driving to help drive the future for technology and also for reduced footprint from emissions and carbon neutrality. But as Dave mentioned, I think I would like to highlight the fact that we get a lot of benefit from engineers helping out with students through SAE. We appreciate the support of SAE in the schools and the marketplace and helping to drive further education for engineers in automotive electronics as we move forward.
Well, thank you to SAE for producing this podcast. And Dave, Monty, thank you so much for coming on SAE Tomorrow Today, because today is tomorrow, tomorrow is today, and the future is BorgWarner. Gentlemen, thank you so much.
Thank you.
Thanks.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us for next week's episode when we speak with leaders from Continental and Voltario about their recent partnership in the development of a fully automated EV charging robot.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.